Hi, before we start, let's see what would be our source video.
Captain's log, stardate 1324.1. On planet M113, we encounter a killer from a lost world.
So the target today is to take a video or an audio and transcribe the audio into words, into sentences. And basically those segments of information will be the subtitles for this video and will be played together. So let's start. As always, the starting point will be creating a new Conda environment. I will leave an install.txt that contains all the relevant information. It will be part of the video description. So first of all, let's create a new Conda environment. Let's name it FastTW, it's Fast Whisper. And after that, we should activate the Fast Whisper. And then we should run a pip install for the faster whisper. Please use the version 1.0.3. Also, it's recommended that you use CUDA version 12.x. If you have a previous version, please upgrade to the 12 version. Great, let's continue to the second step, and the second step will be doing an transcribe for a specific audio file and a very short file. So I will add to the Python code these two media files, and let's start with the a.mp3 and let's play it for a few seconds.
Wisdom will come, my friend.
So we are expecting to see the text "Wisdom will come, my friend." So let's start with the coding. As you can see, the file also here on the left side is a.mp3, and before that we have to change our interpreter to the fast W, the one that we have just created. Here it is, fast W. Fast W is the fast whisper. And now let's create the first Python file. Let's name it step 1. Let's name it step 1 demo.py, of course. Now let's continue with step 1. So from faster whisper import whisper model, and now we have to choose the model size, and let's choose the large one. If we have any performance issue, we can choose and reduce it to the medium or to the small. So large v3. Next we should initiate our model and send some parameters like the model size, the device, if we have a GPU card, it should be CUDA, and also the compute, it's a required parameter, or compute type, let's make it float 16. If you don't have a GPU card, you can replace the device with a CPU, and it's better to reduce the compute type to int8. But as for now, let's leave it as is. Now let's add our file, and this is our file. Let's copy the relative path to this file. As you can see, you can put the full path to the AMP3. I put the relative path, it should be the same. And now this is the moment of truth. We should grab the segments and the info. Segments are the part of the audio that being transcribed to words. So this should be the command model dot transcribe, and we are sending the audio file and also the beam size. Okay, after running the inference, we would like to print the detected languages in this audio file. Basically, we are expecting to see English, but let's print the results. Let's print the detected language and the probability of this detection. I can see that I have a syntax error with the file name. It should be file and not file1. I will fix it later on. So as for now, let's print the detected language. It should be info.language probability. Great. Next, we will run through all the segments. Segments can be phrases, can be words, can be sentences. It's really, we are depending on how well is our model. So let's run a loop through all the segments and print each segment and each time. We also would like to print the timeline. So when exactly in the audio file there is the starting point of the segment and the ending point. I can see I have a syntax error. It should be for segment in segments. So let's fix it. Segment start and segment end. Great. And also, of course, we should have to print the text of this segment. Let's fix the file name. And I think we are ready to run it. So let's run it. And let's see what would be the results. We should wait a few more seconds for loading the model, and now you can see detected language and the text. Wisdom will come, my friend. Great result. So let's continue to the next step. So in the next step we will use a video file. So this one, Star Trek Origin. Let's play for a few seconds and hear it.
Captain's log, star date 1324.1. On planet M113, we encounter a killer from a lost world.
Red modeling all over space.
What happened?
What do you suppose happened, Captain? You beamed down a crewman who doesn't know better than to eat an
I've just lost a
untested-
crewman, Mrs. Crater. I want to know what happened.
So this is our video. Let's take our previous Python code and create another one. Let's call it Step 2 Star Trek. And basically we will run the same process, but instead of using an audio file, we will use a video file. So once again, let's copy the name of the relative path of this video file and replace it. Place the previous audio file, and let's run the same process. Let's wait a few more seconds. We're expecting that it detected as English. Great. And now we're expecting for all the segments, and you can see each of the segments, what is the timeline, and also all the wording. Very great results. So now let's do two things. One, let's translate it to French, and the second one, let's combine everything together, the video, the audio, and the subtitles. So let's move forward for the final step. So let's continue to the final step, which is generating the SRT file, and also let's use the help of Google Trans to translate to other languages. I put many comments on this Python code, so you can go through all the lines and understand, but basically it's the same as we done before. We are starting with importing the faster Whisper, and we also import the Google Translator. The model size is the same, initiating the model is the same, and this would be our Star Trek file. It's the same file as we saw earlier. This is the transcribe process that creates all those segments and words inside of this segment. And now we're getting the list of those segments. Let's create a function to do all the convert between hours, minutes, and seconds for generating those this SRT file. And here we are creating a new SRT file. Let's put it on the same place as our video, so it will be convenient to run the video later and see the result. And here we are doing the same as our previous. We are running through all the segments and calculating the starting time and the end time, and of course the text of the segment. We will print it, and the new issue here that we are writing the text file from each of those segments into our SRT file. So this is the process of creating the SRT. But let's move forward and do some translation. Let's translate the information to French. So let's create a new SRT file, and it will be in French. So we will name it Star Trek Origin French. And once again, we are running through all those segments, and we are using the translator, the one that we initiated earlier, and telling that our source text is English and the destination should be French. Let's print the French result and write it into an SRT file. So this is the basic process. Let's run it and let's see the result. So as you can see here, it generated, let's wait a few more seconds. Great. So as you can see here, it generated all the information in English, and here everything was translated to French. But if we go here to the left, we can see that it generated two SRT files. This is all the text that was transcribed from the video in English, and with the starting point and the ending point of each segment. And here is a similar information in French. But now it will be very interesting to run the video with the subtitle and to see it merge together. So let's go back here. This is our video. As you can see, the SRT file, the English one, has the same name, only the suffix is different. So let's run it. Let's use VLC. You can see the subtitle along with the video. Let's stop it. Great result. So thank you very much. I hope you enjoyed this tutorial. You're most welcome to subscribe. More videos will be uploaded soon.